So next up, we have Emily here. So that's why Emily's on Spotlight. I'm sure Lisa will stick around for at least a little bit longer to answer some questions. If you have any, you can throw in the chat there. I'll throw up Lisa's resources again in a bit before I throw up Emily's direct link to that. But Emily's here to talk about really leveraging the all the different types of things you can do in your CodingRooms course to reduce the cognitive load in your CS classroom. That's the title of the presentation. So Emily, I'll let you kind of kick it off.
Thank you, Joe. So I'm not gonna lie, I was like totally last minute doing some of this stuff because I had so much I wanted to share that I was having a really hard time like narrowing it down and picturing it. So I put my email and stuff in the slides. If you ever have any questions, I absolutely geek out over CS and teaching CS. So I'm more than happy to help with any questions you have ever. I'm going to start by sharing my slides, but then I will move over into the CodingRooms course, which I put these slides in the CodingRooms course. So you should be able to see it on the overview page in the module. All right. So first up, this is me. I'm Emily. I teach computer science at Ideaventions Academy. It's a very small private school in Reston, Virginia. I teach gifted kids from grades 4, 3, starting this year. We're going down to 3rd grade, all the way through 12th grade.
I clicked the wrong button. Sorry, Emily.
Sorry. So I teach from 4th through 12th. I teach APCS, both of the courses, but I also teach 4th, 5th, as well as 6th through 8th as well. So I do Python, Java, Scratch, a little bit of everything. I got my bachelor's of science in computer science, and I decided industry was not for me. Teaching was really where I wanted to be. And I am finishing up, like this week and next week, I'm finishing up my master's from GMU. So if any of you are looking for a master's program to complete, here's my plug for that. They have a computer science specifically focused curriculum and instruction, and I've learned so much from it. So most of that is what I'm sharing today. So I'm just going to do a quick overview of what cognitive load is and why it's important in the classroom. And then I want to deep dive into 3 different strategies. And I also give some examples of how I kind of put all of this together in my classroom. Also, I talk super fast when I'm nervous. So like, I'm going to try and slow it down a little here. All right, so first up, what is cognitive load and why is it so important anyways? Those of you who come from a traditional teaching background are like, duh, this is obvious. But for me, who I just kind of jumped into teaching without a license or degree, this was brand new information for me. So when we talk about cognitive load, we're really talking about how much we're putting onto our working memory. So not just the amount of information that we're putting in our working memory, but also how complex it is. And the goal is to reduce these 2 things to kind of help us learn better and achieve more. So this quote is from the Computer Science in K-12 handbook, and it really just kind of captured the why for me. And that's because we have so many students that come through our classrooms that think programming is so hard and impossible to achieve, but we can really make it more accessible for them by reducing the cognitive load and making some of these things simpler and kind of scaffolding it for them in a way. So where do we go from here? We know that programming is hard. We want to support our students, help them succeed, and also help attract more students to the field. So this is where we're going with some of these strategies that we can use to do this in our classroom. So I narrowed down 3 that I want to focus on today, 3 that I use a lot within CodingRooms itself, and that is Parsons problems, which are kind of puzzle-like problems that students unscramble the lines of code. PRIMM, which is a framework for scaffolding, and then worked examples, which I didn't really make this connection until recently, but if you think about a math book, when you go through the math book, they have examples that are worked out and they have kind of explanations. We're talking about the exact same thing in computer science. So I'm going to go over to CodingRooms at this point. I'm going to everyone, should I share my screen, Joe, or should I just go into presentation mode?
I think just sharing your screen probably works. I'll give
Okay.
everyone the direct link to this page.
Perfect. So this is the second page in my module here, Parsons Problems. I've put a lot of information on here, as well as some resources that you can find more information. I'm not going to like read straight through this, but I wanted to make sure that after today, if you want to go back and view all of this, you can. Let me go into preview mode here. And there we go. All right, so first off, what is a Parsons problem? Really, it is just giving lines or blocks of code to students in a scrambled up format and asking them to unscramble them to complete a programming problem. So the first example that I have here is a perimeter problem. Arrange the lines of code in the correct order so that the program will print the perimeter of a square. So over here on the option side, the students have the 4 lines of code that they need to complete this program, but they're not actually having to write any of that themselves. So this helps students when you're introducing new concepts because they don't have to worry about the syntax of it. They don't have to remember, oh, how do I declare a variable? Or what was that line like when I was trying to print something out? So then they can take these blocks here and put them over here in the solution side. So first, my width is 4. I'm going to set my height variable to be the same as my width. I'm going to make my calculation. And then finally, I will print. One of the nice things about CodingRooms is I can check my answer right away. It'll tell me that I got it correct. If I had something switched in here, it would tell me it's not quite right, but I can keep trying again until I get it correct. So yes, this can create a problem with like guess and checking, but when used correctly, if you have those intentional learners, it really does help to let them look at the logic and the structure of the program and not worry so much about the syntax. I think these originated in Scratch because you were using the blocks and you could just put them out into a program and let students rearrange them. But CodingRooms, there's a couple of other tools out there too, lets you create these Parsons problems straight into your lessons. So I put a couple of more there for you guys to check out. This one uses functions and has an extra line. So I am making them choose what they want or which function call they want to use. So I gave them the example, and then they have to choose which function call to help them realize that the order of the parameters matter. All right, so let me keep going down here. When we think about why they help the learners, it helps them focus on the structure and logic, not looking at the syntax. Also, it's a starting point for them. If you introduce a new concept to students and just kind of give them a blank screen and tell them to solve a problem, half of them are going to look at you like you're nuts. And so this gives them kind of that starting point to ease into it a little bit more. And then you kind of build up to the point where they're then modifying programs before they make their own programs as well. I gave some step-by-step examples or step-by-steps on how to create a Parsons problem in CodingRooms. It's only 12:15. I'm going to take a minute here to actually go ahead and create one so that you guys can see how that's done. So I'm going to just like put a little space here, leave my screenshots there, but put a new one in. So first thing, I type my little slash, and then I'm coming down to Parsons problem. If I can't remember what I'm looking for, I do browse through, but otherwise I just start typing it and it'll pop up for me. So Parsons problem. This first line here is automatically bolded. So I found that it's useful to put this as a title, like question 1, question 2, or even just totally thinking off of the fly here. Let's just do hello world. Next up, I can put in the lines of code I forgot the description. Rearrange the lines of code so that it prints, hello world, my name is computer. Now I can go ahead and each one of these blocks is a separate line of code. So let me try and pull out some Java from my dusty closet here. Hello world. Just type the first line in here. I tend to type them in order when I am putting them into the options here. But the nice thing is that CodingRooms will automatically shuffle them for me as long as I do this little shuffle options here. So as I'm creating a problem, I put them in order on the option side. I make the solution. I drag the blocks over here for the solution. And then I check that shuffle options. That way, when each student gets it, they're shuffled up and I don't have to worry about shuffling it on my side of things. I do have extra ones here, so I can delete those. But if I would need to add more later, I can add options down here below. Does anyone have any questions about how I did that? Okay, I did put screenshots in here for you guys, so that'll make it like super easy when you want to go back to this in like 2 months. I get that these PDs can be super overwhelming. That's a good question. Joe, is this available and free? I think so.
Parsons problems are actually a premium level block.
Premium.
However, you can use Parsons problems in any of the marketplace courses and CS Awesome. So you can still use ones that people have pre-created. You just can't create your own.
Yes, perfect. Yeah, I do know there's a lot in CS Awesome. That's one of the first places that I saw them. Present the correct solution before you can click the shuffle. Actually, the correct solution, you mean like the instant feedback? Oh, no. I can totally, if I don't have the solution on here, I can totally still do the shuffle options before that. I just was kind of presenting it in the order that I went. Yeah, you can click the shuffle options at any point. That's just my last thing that I do. Just my workflow. All right, I did put a couple of resources down here at the bottom. I did not have time to put them in APA format. Master's program is slowly killing me, but this book here, Computer Science in K-12, is such a good resource. There's chapters on just about everything. And then the second one that I'm going to refer to a lot is the Big Book of Computing Pedagogy. This was released by Hello World, which is owned by the Raspberry Pi Foundation. And it is like literally the Bible for every computer science teacher. So between these two resources, I highly recommend them. I'll try to put some links in here later for you guys so that you can kind of link directly to those as well. All right, I'm going to go ahead and move on to the PRIMM framework. This is a close second favorite. Really, this is just a framework that is kind of a natural scaffolding. It was created by, her first name is Sue. I can't remember how to pronounce her last name, but she works for the Raspberry Pi Foundation as well. And so this is kind of it's a research-based practice that provides the natural scaffolding when you're introducing new concepts, or I even use it when I'm introducing like a new library. So the PRIMM stands for predict, run, investigate, modify, and make. The very first thing you do when you are introducing a concept in this model is you give students code and you ask them to predict what happens. So this can look like either doing it as a class, partnering them up, or sometimes I'll have them do it independently and I'll ask them to write kind of what they think is going to happen. This is really helpful if I am looking for misconceptions. I'll be like, oh, okay, so when students look at this, for loop, the very first thing they're thinking is this, and I can kind of help address that as we move forward. After they have predicted it, then they are going to run it. This can be really hard for students because the very first thing they want to do when they get code in their hands is run it right away. But this is having them kind of step back, read through the code, try to understand what's happening first before they start running it. One of my favorite questions in the run phase is, what do you notice happened and what do you wonder? Like, what questions do you have? What are you curious about? Because this starts helping them and me see kind of like what sticky points are in there. And they might notice something new that I didn't realize they weren't understanding in the first place. So after they have run it, now we're getting into actually dealing with the code a little bit. This is the investigate phase. So this is a lot of work on our side of things because we have to pre-plan these activities to find some sticking points of what we want students to really notice and investigate. So for example, they might need to comment out a line of code and then run it again and see what happens. They might change the word hello to hi and see how that affects the code. So there's a lot of different things you can do, and you kind of get to decide what you want to focus on within the lesson and what you really want them to be investigating. The fourth step here is modify. So after they have investigated the code, they should have a really good feel for how it's working. They've already read it, they've already, observed it, they've modified it. They should be very confident at this point with the code. Now we can actually ask them to do something different with the code. This could be as simple as, hey, change the color of the background to something of your choosing instead of what's there originally. Or you can ask them to kind of extend it a little bit. The example I give here is if I give them a program that originally gave or calculated the perimeter of a rectangle, in my modify, I might ask them to calculate the area of it. So it's not like starting from scratch. We're not asking them to make a completely new program. We're just asking them to modify it, take it a step further. And it's just another step in that scaffolding. I hope you guys see how awesome this is as much as I do. All right, so the final phase is make, and this is where you get to get pretty creative with this point, but you do have to be careful not to overwhelm them. And it's also important to note that some students may not be ready for a completely independent make phase right after they've modified. They might need to do a couple of modifies. They might need to do a couple of investigations before they really have a handle on it and are ready to do the make phase. So you kind of have to look at your learners and decide what's best for them at that point. All right. One of my favorite things about this is it helps build confidence in students. They're not staring at a blank screen, not knowing what to type. They have these entry-level points that they can slowly build into it. And then by the time they get to the make, they can be confident about what they're doing and also kind of have that example to look off of as well. How can we use it? I do this a lot when I'm introducing a new programming concept or exploring a new library. I don't always follow it kind of like step by step. Sometimes I'll jump straight into the predict, or sometimes I'll start at predict, other times I'll jump straight into modify. It kind of depends on where we're at and what we're doing. So don't be afraid to kind of like play around with it a little bit as well. I gave some examples of how you might do this in CodingRooms, but I also have linked in the example lessons, kind of an example PRIMM activity that I've done before. So as I look back at this, I'm like, I can make this way more awesome, but I wanted to include it anyways to give you guys an idea of what this might look like. So I have adapted this lesson from Python Crash Course. They have a whole chapter on data visualizations, and they really just like kind of walk through the code and explain how it's working. I threw their code into CodingRooms here, and I created my own PRIMM activity off of it. Originally, I did this with Google Docs and just a regular IDE. But when CodingRooms came around and had this all in one, I was super excited because I didn't have to have students like juggling 2 windows or 3 windows at once. So first step, I give them this code and I ask them to read the code and just tell me what you think is going to happen. No expectations, just give me a prediction. Afterwards, they're running it, and then I'm asking them to give me a response about what was this what you expected, what surprised you, and what do you still wonder? Can CodingRooms include CSV files? Yes. So over here in the files, there's an upload option, and you can select PNGs. We've even done GIFs, CSVs, JSON files, like totally all inclusive. I haven't run into anything that I haven't been able to use. Afterwards, I give them a set of investigates. So there are 5-ish, about 5-ish different things that I'm asking them to do. So the first one here, on line 12, change the 5 to a 6. So if I go over to line 12 here, Oh no, look at me. That's terrible. This is the line that I'm looking for here. Line 15. Change the 6 to a 5. It's embarrassing. It's terrible. And then when I click run, I'm going to look at how this affected what the results were, and then change it back when I'm done. I'll give another example down here. On line 21, put the word day in empty quotations. So down here, I believe it's this line right here, obviously not 21. I have to fix this. And instead I put day here, and it'll let students see that that'll give a label to the x-axis. So they can see kind of like the different options and what the different function calls are doing here. All right, so afterwards, then I go into the modify. At this point, I'm asking them to add a second graph on here. So it already was graphing the daily high temperatures, and now I'm going to ask them to do the daily low temperatures. So they don't have to completely start over. All I'm wanting them to do, here I have my highs dot append. I'm asking them to create a lows list and then plot that as well with an extra x dot plot. For the make, I left it very open-ended. I was just asked them to create a new type of chart, and this is asking them to go into the documentation, explore a little bit, but this is pretty far into my 8th grade year with these students, so this might be a little too advanced if you're dealing with beginner programmers. All right, does anyone have any questions on PRIMM? Oh yeah, that would be super cool if the taglines would like adjust. I don't even know how they would do that though. A part of my problem might be I copied in code from another IDE and then didn't change the assignment. Students always call me out on stuff like that. I just own it. I'm like, yep, I make mistakes. It happens. I'm human. All right. Next up, I have examples. This one is nearly groundbreaking, but I wanted to just kind of throw it out there and kind of show you how I use work examples. The AP labs use this technique, but the questions are buried in text. Yeah, you could actually take the AP labs and put them into CodingRooms in that way. And I also thought about, I saw that CodingRooms added polls. So I kind of gave the suggestion that you could use a poll for student predictions. I saw that when I was creating this lesson. That was a new addition. So I could ask students like, what do you think will happen when this code is run? And then give them these different options and kind of not make it quite so open-ended. But I do, as students are working through those predictions and running the program, I try to be very active in looking at what their responses are. I actually like to use this grid view here. Oh, sorry, it's yelling at me. Example, grid view. So I like to look at the grid view here for the short answers, and that way I can get a very quick view of what those predictions are. I can check the answers and I can like very quickly, especially in the run phase, help address any misconceptions that are going on. For example, like if I can go back and be like, oh, wait a minute, something was definitely supposed to happen. Let's revisit this together. All right, I'm going back to worked examples. Take that off. All right, so when we think about worked examples, I think the best kind of comparison you can make is you open up a math textbook, which most of you are probably math teachers. I have not taught math, but you open up a math or physics textbook and you can see the worked examples of sample problems. It's really the same exact thing. We generally use sub-goal labeling, which I kind of think is just good commenting practice. So there's like a lot of really big words when you're looking at the research with worked examples, but it comes down to giving students examples of programs and explaining to them with the comments how they're working and what they're doing. So I give an example here from an introduction to Pygame lesson. The goal of this program is I was asking students to look at this code and predict what would happen. And I put in some sub-goal labeling here, which is the comments that's giving them kind of the chunks of what's happening. So because this lesson had already what came after how we can initialize a Pygame window, I kind of just chunked all of this into one and put it under the label initialize our Pygame screen. The new part here was how to add an image. So I put two different labels on the two lines that deal with that, load the image from the file, and then copy the image onto the screen with the screen.blip. The main game loop, once again, I kind of chunked it into one label. And then I did explicitly put, we need to refresh our screen. I adapted this example from the Hello World programming book, and I'll show you kind of the larger portion of something that it was included in. But this would be an example of a worked example with sub-goal labeling. It's something that already works. When they run it, they're going to be able to see that it loads the file, the beach ball, and where it copies it to at 50/50. So there's an example of that. For those of you who haven't worked with Pygame in CodingRooms before, one of my favorite things as we worked through this unit was the little arrows up here in the top where I can make it bigger. And then same for my, if I run it again. Running it, open my desktop, and I can make my desktop bigger as well. So if I just want to see my game running, that was like one of my favorite features that they added was the arrows to make it bigger, especially as I have students working on Chromebooks because they're like trying to read this tiny text on the screen. I'm like, no, Connell, like cut it out. You just use this little button right here. Oh gosh, I miss my students, so goofy. All right, so when we're thinking about why these worked examples help students, it's pretty simple. It just helps them practice reading and understanding code. It gives students examples of how concepts are used. And one point that was pointed out in my resources that I really liked was it kind of helps them assimilate the new knowledge into their background knowledge. So if we're looking at for loops that's printing something out, students can look at that print line that they already know, and they can be like, oh yeah, this is how the for loop is working with the print statement. When you're working with worked examples in CodingRooms, there are like so many different options to do it. One is just to put the IDE in there, like this example up here. It's for students to run and kind of investigate. But if you didn't want them to be able to run it, you could use a static code block. And that would, obviously they could copy paste it into an IDE if they wanted to, but they have to like put the extra work into it. So they can just read and comprehend it, but not be able to run the code as easily. You could also give students a partial worked example in an IDE like this and kind of ask them to fill out the rest of it. So you could kind of leave this blank and ask students to fill in the name of their file that they have uploaded in order to make the worked example work. There's also live coding with students. They give it a special name like live worked examples, but really if we're just live coding, you can do presentation mode. Have you guys seen that today at all?
A little bit, we looked.
A little bit, okay. Yeah, so presentation mode, I love. It's fantastic for being able to side-by-side code with students, and we can go through worked examples together. The one downside, which I think you guys might have fixed since this spring, was students being able to copy paste code from my environment, the presentation environment, to their personal environment. I was like, guys, no, like you have to type it out with me. Like it doesn't help you if you're just copy pasting it. But I think CodingRooms might have fixed that since then. All right, so I did want to highlight that I put several different example lessons in here. Full disclaimer, I don't create a lot of like super original content. I tend to take lessons and examples from other sources, and then I kind of adapt them to how I need. So in each of these, I try to be very explicit about where I got the information from so that you can go and find more if you want to. For example, down here, this one's from Python Crash Course. So here's the PRIMM activity. And then I also gave two lesson examples. The first one is drawing with Pygame. So this was something that I did at the end of the year with my 7th grade students, and they were able to work independently through it, which was helpful because students who needed a little more time could take that time. And the ones who went quite a bit faster were able to just like be creative and do their own little independent project at the end. So I didn't follow the PRIMM guideline specifically with this, but you'll notice that it does have a lot of those things in there, kind of like what happens when you run this code, change these numbers to something else, what do you notice next? And then as you get further down, I have some like modify and make as well. Let me get a modify down here. Boop, boop, boop. Here we go. With this knowledge in mind, change the code in the example so that it places the circle in the middle of the screen. So they have to apply the knowledge that the circle is being placed at 100, 100, and then figure out where to put it so it's in the middle of the screen. The other one that I put in here was strings. It's called Strings Revisited because it's kind of later in the year after we've been printing strings, but it's doing all of the accessing individual characters, looking at how we can loop through strings, which, by the way, Python, way easier to deal with strings than Java. If we ever switch to Python for AP, I will be forever thankful with strings. Here down, I included an image here. So I was wanting to kind of like really spell out for students how the characters in a string are broken down in index. So I just created this image really quickly in Google Drawings. And then you can actually copy paste directly in if you take a screenshot of something, or you can import a file. Can you import from GitHub? I would think so. I haven't done it myself though. For Python, is there a curriculum similar to CS Awesome that can be imported? I do know that they had Think Python in there as a curriculum, and there might be a couple of others as well. I think Python is just the one that came off the top of my head. And that's honestly where mine came from. So I did take a couple of things from Think Python and copied them into here because that was the textbook that we were using as well. I also, yes. Here it is. This is the other example that I wanted to put in here. So this is an example of kind of a warm-up activity that I would do with students after I would introduce a concept and we would talk about how we use it. This one's from variables and creating and declaring variables. I give some examples of multiple choice questions, some prediction questions here, and then also a Parsons problem. So this is an example of something that I would give my students before I'm asking them to actually write code themselves. They would have to do these problems. Python for everyone, awesome. All right, so if I go back to my Zoom, what are you doing to me? There we go. This was just kind of the deep dive into the 3 that I picked out that I find most helpful in my classroom, but I did put a couple of extra ideas for you here to explore. I know pair programming is going to be talked about later in the day, so that's why I chose not to talk about it too much right now, but that's also really great for reducing cognitive load, as well as debugging exercises and unplugged activities. I love playing board games, card games, all those kinds of things in my classroom. Right. I'll love to answer any questions that you guys have. I ended a little bit early, but I'm sure you're all very hungry by now too.
No, this is a perfect time. So yeah, let's open it up for some questions. I'll allow people to unmute their mic also.
Very welcome. Thomas? Tomas?
Yeah, so with respect to reducing cognitive load, like on that string revisited example lesson, would you put all of these concepts on that one page? You know, you have the length function and traversing a string and it, or would you like separate them into smaller, different little lessons that you put on?
You could totally put them into different lessons. I try to give my students a couple of, by the time we're getting to strings, this is probably about February in the year. So they're pretty comfortable at this point. When I do the variables, it is very much like, here's how you make a variable, here's how you print a variable. But I can definitely see how it would be helpful to kind of break these into individual lessons as well. I do usually create a module for each of my kind of chapters that we do, but within a module, you can create a sub module and put like 8.1 string as a sequence, and then put the lesson and different examples for that as well. I also tend to do some of the readings together with students. I don't like to set them loose on a lot of readings. I took a literacy in the content area course at GMU, and that like blew my mind on how important the literacy skills are within computer science. So I used to do a lot of just like skipping any reading, and I would just show them how to do stuff. And then I was like, oh, wait a minute, no, I'm totally doing them a disservice. They need to know how to be able to comprehend this stuff as well. So we do a lot of reading together. One thing that I liked to do this last year was we created vocabulary cards, where I gave them index cards and they broke it into term, definition, an example, and kind of an illustration. And then I put them on a ring, so that just like you would kind of in kindergarten with your sight words, so that they could refer back to the different concepts at any time they wanted. So after we got through the strings revisited lesson, we went back through and we made a vocabulary card for strings and the concepts with them. Yes, give the title of the book. So I did put the books in the different lessons. I tried to put them at the top, kind of like this one right here. And I tried to put the link for Amazon too. Python Crash Course is a super favorite of mine for Python. And for Java, I use building Java programs a lot, just because that's what was used my freshman year in CS. But I also like to use CS Awesome for that as well. In terms of kind of pedagogy, the Hello World, and then the computer science K-12, highly recommend spending the money on this. I'm so jealous they gave everyone a copy of that at CST. I wasn't able to go this year. Right. Like I said, if you have any questions whatsoever, please don't be afraid to send me an email. You can connect with me on LinkedIn. I put my contact info in the slides on the first page here, so you'll have access to those as well.
Awesome.
Great.
Thank you so much, Emily.